this is the last important phase that we are talking about in blood clot. This is the coagulation phase. And in your graphic organizer, I have this set up. So you might take a second to just write down the visual representation. Key thing to remember, there are two main pathways kind of converging together. So there's an extrinsic pathway, there is an intrinsic pathway. So as the name would suggest, extrinsic is based on external factors other than the blood. Intrinsic pathway refers to the blood related factors. So the coagulation phase can be initiated by either of these conditions. However, the final step where the final clot is created has to go through the common pathway. So you can notice they all converge to factor 10, factor X or factor 10. And from there, the final blood clot is created. So going back now, let's look at some of the key features of these pathways. So let's look at the skin. Skin is covered with different membranes. So this is the epidermis, dermis, and the subcutaneous fat. This is the layer that you would find in the blood vessels or in the skin. So if there's an injury, the damaged cells the damage will be filled with blood. Platelets, red blood cells, and the fibrin net form a solid clot. This stops any more bleeding. The clot hardens and new skin is formed underneath. The clot is dissolved away, leaving a hard surface, which we call as the scab. And eventually the scab is completely removed. So, in order for the process to start, the extrinsic pathway begins in the blood vessels or the cell wall. And if there is a damage to the cell wall, tissue factor TF is released, and that will in turn activate the X factor, factor X. So tissue factor activates the X factor if there is injury to the vessel, blood vessel. Intrinsic factor could be if something is going on in the bloodstream. Within the bloodstream, if there is, say, different types of microorganisms present, or if there is a pathogen there, that could cause clotting as well. And it is activated by enzymes, collagen. And they release platelet release factors, which in turn again then go on to activate factor X. Once the factor X is activated, then the common pathway is initiated, where intrinsic and extrinsic pathways converge. So essentially now it's the job of only two things: enzyme prothrombinase that converts prothrombin, which is dissolved in blood, to thrombin. Thrombin then converts fibrinogen, which is, remember, it's one of the blood plasma proteins. It converts the plasma protein into fibrin. Fibrin is insoluble in the blood. It kind of settles down, so it becomes the fiber, and it seals down that area, literally blocks the blood from going out or any other foreign object, whatever it may be, from coming in. That is the blood clot. Now, this is another visualization of that blood clot. You can see the intrinsic pathway goes through certain cascade events. Extrinsic pathway is only initiated through tissue damage, and how those two pathways converge in the common pathway. And the final step is the formation of fibrin. Fibrin then converts into a fibrin clot.